everyone. Okay, myself Lakshmi Bai. Okay, I am working in the SCC college, Kolar. Okay, so now I am going to discuss about the subject is nothing but the system programming. In the system programming, I am going to discuss about the compilers chapter. In that one, I have taken one topic is nothing but the phases of a compiler. Okay, so before going to the phases of a compiler, first of all, you have to explain what is a compiler. So as you know that the compiler is a one program translator which is converting a program of high level language to the machine level language program. Okay, so the compiler definition I already said that. Now you are showing the diagram of a compiler definition. That is the program, that is source program is written in the high level language. Okay, that program can be converted to the machine level language program, or it is also called as a object code or object program through one translator. That translator is nothing but a compiler here. Okay, now we are discussing the topic is nothing but the phases of compiler. So before going to the phases of the compiler, I should tell why you have to take the phases of compiler. Okay, compiler is a very complex process that cannot be executed in a single step. So what we have to do means the compiler must be divided into a number of sub functions or sub tasks. That functions or the task is nothing but the phases. So only you are discussing the concept is nothing but phases of a compiler. Okay, and phases is also nothing but a cohesive operation. What is the meaning of cohesive operation? Cohesive operation is nothing but we have taken the input in one representation, we are producing the output in another representation. That is nothing but the cohesive operation. Now, in the phases of the compiler, there are totally 6 phases are there that have shown in the diagram. Okay, so what are the 6 phases there? The first one is nothing but lexical analysis. Second one is nothing but syntax analysis. Third one is a semantic analysis. And fourth one is the intermediate code generation. And the fifth phase is nothing but the code optimization. And the sixth one is nothing but code generation. So there are totally 6 phases of the compilers are there. Along with that 6 phases, there are also 2 activities are present. What are those activities? That is nothing but one is a table management, other one is a error handling. Okay. Now we are going for the each and every phase in detail. Okay. Okay, now we are going to discuss about the each and every phase individually. So we already discussed about the 6 phases. Okay, in that one you will be having the first phase. Which is the first phase? That is nothing but lexical analysis phase. So in the lexical analysis phase, the main function is nothing but you are completely scanning the source program. And after scanning, you have to generate output. What the output you will be giving is nothing but you will be having the sequence of tokens as an output. So you have to remember that you are scanning the source program as an input and you are producing the output is nothing but sequence of the tokens. Now I will go with an example I will take. It will be better if I take example. Okay. So what is there? We have taken an example. This is the 4 lines of a C programming code is there. So in this one you are checking that if A is less than B, then we are giving the initialization of C. That is C is equal to C plus 5. If it is not A is greater than B, at that time go for the else part. In the else part, I am going to incrementing the C is by 10. That is C is equal to C plus 10. This is nothing but your general C program. But now I am going to generate the sequence of tokens. So the tokens will be having the categories. That is, the tokens can be either identifiers or it may be literals or it may be the terminal symbols. Okay, so the terminal symbols is nothing but it is a collection of operators and the keywords. Okay, so for this example, I will generate the sequence of tokens. After that, we are going to generate the table, that is uniform symbol of first line will be represented. Now we are going for the first one is nothing but sequence of tokens has been generated. In the sequence of tokens, each and every code, that is if is one token, open parenthesis is a token, variable A is a token. So each and everything is represented in terms of a tokens. So that particular lines 1, 2, 3, 4. 4 lines is represented as a set of 4 lines of tokens. Okay, so what is it? First, if is keyword, then open the parenthesis. So it is the operator will come under the, it is a terminal symbols there. Then A is the identifier, less than is an again come under the categories operator. Then B is also an identifier. Then you are having closed parenthesis. Then like that for each and every line we are generating the tokens. The tokens are nothing but it is the individual units of the particular line. Each and everything will be taken as separate token. So this is nothing but sequence of tokens has been generated. Okay. Now these tokens will be represented in the table. So when I representing the table, the three classification is required as you have seen. So what is the classification? Either it may be the categories of terminal symbol, or it may be an identifier, or it may be a literal. So here completely words cannot be written. So I will just modify with some shortcuts. That is, TRM indicates a terminal symbol, IDN indicates the identifier, LIT indicates the literal. So now we are going to show how the table has been generated. That is, uniform symbol of the first line. Only I cannot write complete 4 lines. I will take only first line. For that first line we are generating the table. So now I will show how you are writing the table. Okay. So here which is class, whether it is a out of that three classes, whether it is a terminal or it is an identifier or it is a literal, you have to represent. Okay. So what is here? Then PTR. PTR indicates a pointer to that particular line. Okay. Here it is nothing but link field. Okay. So here first one, what is the first line? If is a keyword. So, okay. So it will come under the category nothing but terminal symbol. Then open parenthesis. Open parenthesis is a, again it is a terminal symbol. Okay. So as you can see here, I show that terminal symbols are nothing but either it may be a operator or it may be a keyword or it may be any constant we can take. Then A is a variable. So variable is nothing but called as a identifier. So it is represented as IDN. Then we are having B. Sorry, less than symbol. Less than is also a operator. That is also taken as a terminal symbol. Then B is also an identifier, and closed parenthesis, this is also a terminal symbol. So this is nothing but the uniform symbol table of the only one line is generated. Like that, how many programs lines will be there? All the programs will be generated in the similar fashion and tables will be completed. Yes, now we are going to discuss about the next phase, that is syntax analysis phase and semantic analysis phase. Second and third phases are discussed in detail here. Okay, so what is your syntax analysis? So the word syntax indicates the rules must be followed for any programming language. Okay, so like it must be valid or not. So it may be of a number of statements are there, that is assignment statements, conditional statements, like that a number of statements are there. Whether that is written in the proper syntax or not, that must be verified by this phase, that is syntax analysis phase. Now here what is this one? So the syntax analysis phase will be having the groups of various tokens together into a syntactic structures. In the previous phase I taken a single particular if is a one token, open parenthesis is a token, but what I am making, complete line is taken as one syntax. That is nothing but we are making the group of tokens to make it as a syntactic structure. Okay, that is the main part of your syntax analysis phase. So in this one we are verifying whether the syntax is correct or not. If the syntax is wrong, then definitely you get one error dot, the syntax is incorrect. There is no mistake is in the particular line. So like that we will be getting the errors in the program also. Okay. So now what I am making means I will take one example here. Okay. In that example, previously I have written the 4 lines I have written, but in that one I have taken only one line here. That is if open parenthesis A is less than B. This is nothing but one statement. We are comparing the two identifiers A and B. So the A and B are the two identifiers compared. So it will come under the category is nothing but conditional statement. We are verifying the conditions. What is the condition? Less than. So it will come under the category is nothing but conditional statement. We are verifying whether the statement is a valid or not. So according to the rules, it is following all the rules. So this is a valid conditional statement. We'll take one more example, that is a assignment statement. As you know that equals is an assignment operator. Whatever written on the right side of the equals will be assigned to the left side of the variable. So in this example we have taken C is equal to C plus 5. Okay, this is nothing but equals you have written. Okay, so this will come under the categories assignment statement and it must be terminated by a semicolon. So semicolon is a terminating symbol for the particular line. So it is also following the rules. So it is also a valid assignment statement. That is, whatever written in the program, each and every line will be verified whether the syntax is correct or not. That is done in the statement. That is nothing but the syntax analysis phase. Now we are going to discuss about the next is nothing but your semantic analysis phase. So what is a semantic analysis phase? Here the semantic analysis phase will examine whether the types and values are matching or not. It is a process where types and the values are must be matched. Okay, so what is here? I will take it will be, so I give an example that will be clarified what is the statement I am saying. So I will take one statement. C is equal to I am working. I am working is a data type is string, but we define the C as a integer. We define the C as a integer, but either this statement is an integer? No, it is a string type. So it is again the values and the types are not matching. We should assign the value is C is equal to 10 or 5, but we are assigning a string of statement as for the value of C. So this is an invalid. So this will be verified whether the types and values are matched or not will be done by one phase, nothing but your semantic phase. So now I am going to discuss about the concept is nothing but the intermediate code generation, which is nothing but your fourth phase. Okay, so previously we discussed about the three phases. Now we are going for the fourth phase. In the fourth phase, we are nothing but we are going to discuss about intermediate code generation. So code generation means there will be two categories. One is the intermediate, other is the final code generation. Final code generation is nothing but the program is completely converted into object model. It is given for the target program. But in between, before that one, we are converting into the saving into the small parts. Small parts will be saved. That is nothing but intermediate code generation. Okay. So now, so what is you are doing here? Intermediate code generation. In this one, it is exactly closer to, not exactly as target program. It is closer to your target program of the object code. So I am going to explain here. Then we are having the different kinds of representation of the intermediate codes can be done. Okay, for each and every individual line, I can represent in different manners. So there are three different kinds are there. First one is nothing but postfix notation, and second one is nothing but the parse tree. Parse tree is also called as a syntax tree. So parse tree is also called as a syntax tree, and the third one is nothing but triple or tree address code. So example for a tree address code is nothing but a matrix. Okay. Now we are going to display these all these three different kinds with a simple example. Okay. So you can solve it and you can apply for the different examples also here. So I am having here. So first one is what is the first one? Postfix notation. Okay. So postfix notation means first we are having the expression, arithmetic expression can be represented in three different forms, that is infix notation, prefix notation, postfix notation. What is infix notation? If an operator is placed between the operand, then it is an infix notation. If an operator is placed before the operand, then it is a prefix notation. If an operator is placed after the operands, then it is a postfix notation. So here you can see infix as well as postfix expressions. Infix means between the operator I have placed the plus there. Okay. So example here A plus P within the parenthesis, then star indicates a multiplication, then followed by C. This is the representation is nothing but infix notation. Now you have to convert that infix notation into the postfix notation. To do that one we are having there First you write the two operands. When you are doing this one, you have to follow the rules also. That is, priority you have to see. In terms of operators, priority must be seen. Okay. So in addition and multiplication, multiplication is higher priority than the plus. But you can see that I have taken the first is plus only. Why means the parenthesis having the highest priority than the multiplication. So that reason first you have to solve this one. A plus B is represented as AB plus, then followed by C of operand, then followed by operator. This is a small example for your postfix notation. Now we are representing this postfix notation in the parse tree. Okay, when you are representing the parse tree, it is the tree will be having the root and the nodes. Okay, so root is nothing but your operators. Okay, it is having the parent-child relationship is shown here. This is nothing but an operator, and two parts will be having there. That is nothing but the children of it. So one may be an operand or it may be an operator. Operator again is having the operands. So in this one we are going here. We have to go from the right side, which is the first one, star. So star is represented as a first one, root node. Then from that one, for that one you are having two options. One is C, other one is plus. So I write it on the C on the left side. Then I written the plus on the right side. Then for this plus again two operands are there. That is A and B are the two operands. So this is the parse tree representation for your postfix notation. And you can see that as I have dotted something here, dotted lines are represented as M1. So M1 which is required for the next notation as shown. Okay. So now here, what is the next notation? Matrix or the triple notation. In the matrix or the triple notation, we are having the three columns. Okay, what is that one? Operator followed by operand 1 and operand 2. Okay, so you are having here 1 and 2. So 1 and 2 indicates the rows of a matrix. The rows of the matrix is also represented as M1, M2. M1 indicates the first row, M2 indicates the second row. So here, what is the first one? First you have to solve this one, then only I can for the further. So what I will make it here? In this example, plus is an operator, A is the operand 1, B is another operand. And it is residing in which line? First line. So come for the next step. So you are representing here operator. What is the operator? Plus is the operator, and C is a one child, that is written here. Then what is 1/4? Here this completely is written as a M1. Why it is M1 means for the matrix first row. So I am writing as a M1. So now we are going to discuss about the next phase, that is your fifth phase. It is the fifth phase, code optimization. Okay, so the code optimization is here. What purpose we are going for the code optimization? That is for improving the intermediate code. That is the previous to this phase is nothing but intermediate code generation. So in that one some extra lines will be there. So that lines can be eliminated by this phase nothing but optimization. Optimization is meaning is nothing but reducing. That is, for example, 10 lines of code will be there. That 10 lines of code can be reduced to 6 lines. There we are saving the memory of 4 lines, isn't it? That is nothing but for that reason we need the code optimization. So now here, so what is the output we will be getting? You also said that it is getting the output is nothing but reduced length of the program. 10 lines of the code is reduced to 6 lines of the code. Then, so the code optimization can be classified into totally 5 different types. First one is peephole optimization, second one is local optimization, third one is global optimization, fourth one is loop optimization, and the fifth one is the whole program optimization. Okay, so now we'll go to the one after the other. Okay, so what is peephole optimization? The peephole optimization is always applied at the almost at the end of the compiler phase. Okay, so ending of the compiler phase we are applying this peephole optimization at the end of the program. Then for what it will take few instructions will be taken and modifications will be done for that instruction. That is nothing but peephole optimization. Next one is nothing but your local optimization. Local optimization, the word only says that, for example, you heard the word local variables, global variables. What is local variables? The variables which are within the main function is nothing but the within one function is nothing but local variables. Global variables means the variables which can be asked for any functions including the main in that particular program. That is nothing but global variables. Similar concept is applied here. Local optimization is nothing but it is applied only for the single block of the code. So that is single basic block will be applied in case of local optimization. It is operating on only single block. Then come for the global optimization. Global optimization will be applied on entire program. So that is nothing but it is applied on complete flow of the single procedure. Means for complete program we are applying the global optimization there. Then we are having the loop optimization is there. What is a loop optimization? So in the loop optimization you heard the word looping statements. Looping statements is nothing but a iterative statements. Iterative statements mean the statements which are repeated n number of times until the condition fails is nothing but the looping statements or iterative statement. If you are applying the optimization in case of looping, that is nothing but the category is loop optimization. So in the loop optimization, where more time will be spent. That is, for example, the 10 lines of code will be there. In that one, loop is having 3 lines. So that 3 lines will be repeated for n number of times. So the more times will be spent by the processor is nothing but your looping only. That is, example, for I is equal to 1, I is less than or equal to 100, I plus plus some set of code is there within that. So that set of code will be repeated how many times? Totally 100 times. If the set of lines within the loop is 3 lines, for example, I consider 3 lines, 3 into 100, totally 300 lines will be repeated in case of a looping statement. Program is length is 10 lines only, but looping is a 300 lines. Now you can only say how it is a optimization done must be done on the loop also. Then last one is your whole program optimization. Whole program optimization is also called as a inter-procedural. Inter means combining. We are combining 2 or more functions with the main function. That is nothing but inter-procedural or whole program optimization, which will be having a main function. Along with that main function, sub-functions can also be there. So it's nothing but optimization will be between the procedures. That is, different functions will be there. That functions is all nothing but a procedures. Between that one, we are making the optimization. That is nothing but whole program optimization. So now we can say that code optimization. What is code optimization? Then where you are applying what is the purpose of the code optimization. Then we are going for the types of the optimization. Then we are discussing all the 5 types of the optimization techniques. Okay. Then after 5th phase, we are going for the next phase. That is nothing but your 6th phase. What is the 6th phase? The 6th phase is nothing but code generation phase. So this is your final phase. After this phase, you are getting the final program. Okay. So here the object producer will be depending upon the memory locations for the relocating that code for each time, that is each data item, and selecting the register. This definition is explained with this example. It will be clarified there. Okay. So what is here? C is equal to C plus 5. Means here C is one variable and 5 is one literal. So we are using this C is equal to C plus 5. This statement can be operated within the processor by not by taking C. C will be stored in some registers. That is the concept where memory location will be relocated code for the data item by selecting the registers. So for example, I will store the C in one register. So I will take the register is R1. Then how it can replace? C is equal to C plus 5 can be represented as R1 is equal to R1 plus 5, where R1 indicates the register 1. Yes, after completion of the phases, now we are going to discuss about the 2 activities which are shown in the phases of a compiler. Those 2 activities means one is the table management and the other one is nothing but the error handling. So there are 2 are there. So we will discuss these 2 are the activities in the phases of a compiler. Okay. So what is your table management means? The data structure will be used to record the information, okay, in the tables. So that tables is nothing but a uniform symbol table. So a number of different tables will be monitored by all the different phases of a compiler. So for one page you can monitor one tables. Like examples are uniform symbol table, literal table, then identifier table. Like that, a number of tables can be constructed. So all these tables will be monitored by the table management. So what are the symbols will be present in the tables we are showing here. So the types of the symbols which are stored in the symbol tables, it may be either variables, procedures, functions, labels, defined constant, structures. So variables mean the value which can be changed for the identifier. That category is nothing but your variables. Procedure, for the procedure also I need the table. For that also I am monitoring that. For the functions also we need the table. For the function you will be having your function name is required, function prototype is required, function definition is required, return type of the function is required. All those will be monitored for the functions. Then coming for the labels. So in your programs you are giving some label to indicate the jump statement, jump to loop 1, jump to loop 2. Like that labels are defined. That labels also will be monitored by this symbol table only. Then you are having defined constant. Defined constants are nothing but the global constant which are defined, which is accessed by all the functions. Like one example, if I am defining ash define pi value is in that 3.142. Like that you can have the constants can be defined. That also monitored by the table. Then you are having the structures. Structures is nothing but it is one heterogeneous data collection which is having different data types. So that structure is also maintained by the table. So all these are the different types of the symbols which will be stored in the symbol table, and this will be monitored by the table management. Okay, now we are going for the error handling. What is there in the error handling? We are monitoring the if after execution if any errors are executed or any errors are present, thus must be shown and that errors must be rectified. That is a task of the programmer. Okay, so now we are coming for error handling. In the error handling, we are having error handler. For that only separate software is there to monitor the errors. That is nothing but the error handler. Okay, so when the program is executed, when the flow of the program is executing line by line, the errors may be generated. That errors will be given for the error handler. That error handler will display a message that error has been occurred in the particular line. That error must be rectified, then only you can get the target program. So there is no compulsion that it will be operated only in the last phase. So it will be operated in each and every phase. If any errors are generated, that will be monitored by the error handling or error handler. So there are types of the errors given there. So what are the different types of the errors can be occurred in the program? Okay. So the first one is nothing but lexical error. Second one is syntactic errors. Third one is semantic errors, and the fourth one is a logical errors. So if you go for the lexical errors, where what type of errors will be called as a lexical errors? For example, when you are writing the word else is having the spelling is ELSC, but I have written ESLE. So that is spelling is mistake. So if any spelling mistakes are there, which is not a keyword having the different spelling, but your writing is different. At that time, the errors will be generated. If any spelling mistakes are there, the errors will be generated. First type of errors is nothing but the lexical errors. Okay. Then syntactic errors. Syntactic errors will be occurred when the parenthesis, example is unbalanced parenthesis. That is, the balance of the parenthesis compulsory to make it the complete statement. So parenthesis is open, there is no closed parenthesis corresponding to that. So immediately you get the error. Such type of errors is nothing but the syntactic errors. Syntax is mismatching. Okay. Then semantic errors. So for example, I defined only 4 variables. I am using 10 variables in the program. The variables it is not defined is using in a program. That type of errors will be generated by your semantic errors. Okay. Then logical errors. If there is no syntactic error, there is no semantic error. But within the program, the logic is having the mistake. That logic will be not display. Error will not be given. But the programmer should go for the program. Again, you have to verify that where the mistake is there in that particular one. So that is nothing but logical errors. Logical error will not be displayed. But the programmer should analyze the error and how to rectify the error. Example is nothing but infinite loop. So there is infinite loop that means the loop has having no termination is nothing but an infinite loop. So this completes your phases of a compiler. Okay, so we discussed the different phases. For each and every phases explanation is given, and last one is nothing but two activities that has a supporting in each and every phase of the compiler has been discussed. Thank you.